Hello everyone, welcome back to my channel. Today we are going to see error detection. Let's see. Error is a condition when the receiver's information does not match the sender's. Digital signals suffer from noise during transmission that can introduce errors in the binary bits traveling from sender to receiver. That means simply 0 bit may change to 1 or a 1 bit may change to 0. After that, types of errors. There is a two types of error: single bit error and multi-bit error. First we see single bit error. A single bit error refers to a type of a data transmission error that occurs when one bit of transmitted data unit is altered during transmission, resulting in an incorrect or corrupted data unit, as you see in a figure. It is a single bit error. Second one is a multi-bit error. A multi-bit error is an error type that arises when more than one bit in data transmission is affected. Although multi-bit errors are relatively rare when compared to single bit error, they can still occur, particularly in high noise or high interference digital environment. As you see in figure, in data transmission there is a two multi-bit errors. Let's see the error detection. Error detection is a common technique to introduce redundancy bits that provide additional information. Various techniques for error detection include single parity check, two-dimensional parity check, checksum, and cyclic redundancy check. Cyclic redundancy check we also call it as a CRC. Let's see one by one. First one is a simple parity check. Simple parity check is a simple error detection method that involves adding an extra bit to a data transmission. It works as a 1 is added to block if it contain an odd numbers 1, and 0 is added if it contain an even number of ones. This schemes makes the total number of ones. That is why it is called as a parity checking, as you see in a figure. Sender have a 10011, then after that compute parity bit, then we added 1, then transmitted media, then it is a even parity. Let's see the another one, two-dimensional parity check. Two-dimensional parity check bits are calculated for each row, which is equivalent to a simple parity check bit. Parity check bits are also calculated for all columns, then both are sent along with the data. At the receiving end, these are compared with the parity bit calculated on the received data. This is all about two-dimensional parity bit. As you see in a figure, this is a one kind of example. Original bit is then uh, we adjust original bit in a row and columns. In row we added 0, in column we added the addition of original bits, then we receive one new data, then we added to a last of the original data to be, then it is known as a two-dimension parity check. Third one is a checksum. Let's see. Checksum error detection is a method used to identify errors in transmitted data. The process involves dividing the data into equal sized segments and using one's complement. To calculate the sum of these segments, the calculated sum is then sent along with the data to the receiver. At the receiver's end, the same process is repeated, and if all zeros are obtained, In the sum, it means that the data is correct. Let's see with example. First, Firstly, data is divided into k segments, each of m bits. Means original data 1, 2, 3, 4. Means this is k is equal to 4, m is equal to 8. 8 is a data bits. Okay. After that, on the sender end, the segments are added using one's complement arithmetic to get the sum. The sum is complement to get the checksum. The checksum segment is sent along with the data segment. After that, at the receiver end, uh, after completion sender, uh, we moving to the receiver end. All receiver segments are added using one's complement arithmetic to get the sum. The sum is completed. If the result is 0, the received data is accepted, otherwise discarded. And we get a received data in the form of 00, then our data is accepted. It is all about checksum. Let's see, the last one is a cyclic redundancy check. Uh, that is a CRC. Unlike the checksum scheme, which is based on addition, CRC is based on binary division. In CRC, a sequence of redundant bits called a cyclic redundancy check bits are appended to the end of the data unit so that the resulting data unit becomes exactly divided by second predetermined binary number. At the destination, the incoming data unit is divided by the same number. If at this step there is a no reminder, the data unit is assumed to be corrected and therefore accepted. A reminder indicates that the data unit has been damaged in transit and therefore must be rejected. Let's see this with one example. Original message is 1010000. It's our original message. After that, perform after that the side generate polynomial x3 plus 1. Then we generate CRC generator 1001 4 bit. Okay. After that 4 bit, using this we divide our original message by this, then we lastly got 000, and this is a accepted, then it is a CRC. After that, uh, advantage and disadvantage of data error detection. Let's see one by one. First one is a keeps data safe, ensure the integrity and security of data during transmission or a storage, find mistake early, detect errors promptly, preventing the propagation of corrupted data, saves money, reduce cost associated with data corruption, retransmission, and potential system failure. After that, disadvantage, extra data requires additional bit for error detection, increase the overall size of the data, more complicated, adds complexity to the system which may require more resource and maintenance, and doesn't always fix error, identify error, but does not correct them unnecessarily, mechanism for error correction. Thank you for watching.